Hello, everyone, and welcome to today's webinar on the 7 steps to select the right architecture for your web application. Before we get started, I want to mention that you have joined today's webinar muted and can listen in using your computer speakers or your telephone. You will find both options in the attendee panel on the right-hand side of your screen. During the presentation, we invite you to write in your questions using the questions box on your panel. These will be collected, and we will address some of them at the end of today's presentation. With that, let's get started. I would like to introduce Reed Maloney. Reed is a product manager for our web application solution.
Well, thanks, Jeff. I'd like to welcome everyone today. Thanks for attending. With this webinar, we're looking at the fact that you're looking to deploy or build your application, and you really want to select the right architecture, the one that helps you to optimize for, let's say, cost or reliability or performance that will really meet the needs of your particular website or web application. And we're going to take you through really 7 basic steps. It's sort of a decision tree in terms of thinking through the flow of the decisions that you'll need to make to end up at what is essentially a reference architecture that should work very well for your application. So in terms of running web applications on AWS, I mean, the main question is, like, do you want to focus your time on operations, or do you really want to focus your time on developing your application, adding features, making your app or website better? And what we really do is we really help you to focus on that on your application instead of the operations, because you really need 5 things to ensure that you can focus on your app. You need your environment to be available, and you need your environment to be scalable, and you'll need to be able to access those IT resources quickly. You'll also need your environment to be secure, and then so that, again, you can continue to focus on the application, you'll need to know that it's cost-effective and low-cost overall. And so this is really what AWS provides overall for web applications. So let's start talking about the first decision. It's really step 1 in the decision tree for running your website or web application on AWS. And so the first question is your app dynamic? So most apps, they use servers or virtual machines to deliver their web app or website. But with Amazon Simple Storage Services website feature, where Amazon S3 actually can act as the origin for your website, you may not actually need Amazon EC2 to run your web app or website. So these are sort of four parts of is your app dynamic. And so your website, it's probably static unless, number 1, your customer needs to log in. You want to let your customers post content or media to your site. If you are serving actually personalized content to different segments of users that hit your site or application. Or, which is number 4, if you have logic or calculations that are really too large to process on the client. Basically, if you can't run your application as a JavaScript application and you need to have that application running server side, that would be another example of when you're really going to need to use a web server or an application server as part of your architecture. However, if your website does not need any of the following, if you do not have people that need to log in to your website, if you don't have the need to have users post content on your site, and if you're not delivering that content dynamically and there's no, we'll say, real application functionality to the app, so such as, let's say, a content site, a news site, a media site, a marketing website, then you probably have a static website And we'll talk about what that architecture looks like here. And there's a lot of advantages to having this sort of simplistic architecture for your website if your app is truly not dynamic. So our static website consists of 3 main components. Amazon S3, which really hosts the website. It's your origin for your website files. You have Amazon CloudFront. Again, Amazon CloudFront is our global content delivery network, and this will ensure that your website is delivered to your customers fast. And then we have Amazon Route 53, which is our DNS service, which will ensure that your customers are routed to the correct edge location based off of latency-based routing. And so what Route 53 actually does is it analyzes the internet traffic in real time to ensure that requests coming from different locations are routed to the edge location, which can then deliver the information the fastest rather than just the shortest distance. So one of the advantages of this architecture is that it's scalable, it's reliable, and it's low cost. And if you can see the link on the bottom of your screen, those are actually step-by-step instructions that would help you set up this architecture and get started. So there's a couple best practices really for using for creating a static website. Is you really have a couple choices of how you build, of ways you can use web design tools that are available to build these sites today. So you could use a product like Dreamweaver on your locally. You could then create the site locally and publish the entire site with an HTML output. You would just then upload those files to Amazon S3. You would configure CloudFront to work with S3 as the origin, and then you would route your users to using Amazon Route 53 to your Amazon CloudFront edge locations. Another way to build the website, if you don't want to, use, let's say, write a lot of code, you could start up a CMS like WordPress on Amazon EC2. You could then design your site, and then you could end up publishing that site to Amazon Simple Storage Service and then shutting down the Amazon EC2 instance when you're not trying to author new content for your site. Another way to do this is actually just use a static website generator, such as a product called Jekyll, which is Jekyll, and there's others online as well. If you just do a search for static website generators, again, these can help you build the websites without needing to have significant experience with HTML, CSS, or JavaScript. But also you could, this really helps you if you just have a front-end developer and limited, we'll say, back-end or server-side developer skills to be able to run a website that's highly scalable and reliable, and again, extremely low cost. So talking about the cost of this particular architecture is that it's really going to be driven by content delivery. And so if you're monetizing your site on a per impression basis, you'll actually really be paying for each page on that same per impression basis. So you get a really nice alignment of revenue to cost, and you'll know exactly sort of your margins for delivering advertising on your static site. So for example, in terms of cost, if you have, let's say all of your pages are 0.5 MB, and the average visitor is looking at 2 pages, it would cost you $1.20 a month to serve 10,000 users. So that should just give you just a rough example of what an architecture like this costs to run. If your website is not static, you will actually see us in the next questions as we go through this decision tree to really build on this particular segment of the architecture. It's going to stay with us as we add more complexity to overall architectures. because you can still take all of your static content, such as, let's say, your CSS files, your HTML files, your media files, and still present them to the customer in this way. And that will really help you to minimize your overall web server and database footprint, which will really help you reduce your costs. It will also get your content out closer to your customers so your pages load faster. And if your whole site is on multiple different edge locations, you get this really big advantage of reliability where your site is sort of up on the edge. Even if there were to be a problem with your web servers later, your site would still be out. It would be stale, but it would be active, and so your users would still get a return if they're requesting your pages. So we're going to move on to step 2. So step 2 is, can your web app run on just one virtual machine? Can it run on one virtual machine and one database, or is it larger? And while this step is mainly a function of size, there are other considerations as well. So we'll cover those. So if your app is small enough to handle your peak number of users at any time throughout the year, then you could have one virtual machine that has 2 different roles, really the web server and the database. Also, if your site is a little larger and you need one web server and one database to handle your peak demand, that might be a better architecture for you. However, you'll want to make sure that your site is not so large that it warrants having multiple web servers in the configurations we're talking about. Because if it is, you're going to be moving on to sort of what we'll say are larger architectures, or really the next step up. And so the smaller ones we're talking about are really just one VM and one VM and one database. So if your app is small enough to be configured in either of these ways, again, there's a couple additional things you should note that you're potentially giving that could be an issue depending on your needs for your site or your application. So one of them is availability. Is you're not going to be geographically dispersed into our multiple fault-tolerant availability zones. So this is going to be essentially a single availability zone deployment. And so if there were issues with your site, you wouldn't be able to have basically still be running in a different availability zone to have a more highly available architecture. And we'll cover another one in terms of having the database on sort of the same aspect of the web server as we go through this architecture. So really, just like the static website architecture, you should be able to see those components, Route 53, CloudFront, and Simple Storage Service. That's still right here. What we've really added, again, is the Amazon EC2 instance, and then also our Elastic Block Store, which is really disk storage for your Amazon EC2 instance. And so in this case, we're talking about one that's for actual storage needs for your site rather than something that's often called a boot volume, or the volume that you may launch with that instance that contains, we'll say, that some of the software that's helping to configure that instance to be the type of server that you want it to be. So there's a couple best practices for this architecture. First, you're going to want to put your instance, that single instance, in an auto-scaling group with a min of 1 instance and then a max of 1 instance. That way it won't go above 1, which you'll want because you know that your site can just run with 1 instance. But also, if you're, for whatever reason, if that instance fails and you have the min set as 1, the auto-scaling group will automatically reboot that instance for you. Also, with using EBS for storage, and while EBS is durable, it's not as durable as Amazon Simple Storage Service, or S3. And so you can snapshot the storage from EBS into S3 to have the 11 nines of durability that you may require for either your website or web application or different parts of data that you're looking at. Again, the one thing we talked about a little earlier was having this web server and database on the same VM. And the one thing you should consider is that this web server is going to have port 80 or port 443 open to be able to serve traffic to your customers. And so you're going to have your database in the same security group and in the same virtual machine as your web server. And so it's not a best practice for security, so really consider the types of content that you'd be putting into that database since you wouldn't have a separate tier overall. And so you could use this EC2 instance to do multiple different things, such as it could host a content management application such as WordPress, and you could run the dynamic portions or the interactive portions of your blog or website through that WordPress CMS. And so we'll talk about the pricing differences here. So in this case, EC2 has a bunch of different pricing options. They really fall into two main categories for this type of application, which is on-demand or reserved instances. And reserved instances are a pricing model in which you're going to pay some money up front to have a lower hourly usage cost. And there are 3-year and 1-year reserved instances. And for this case, what we're going to do is we're going to look at a micro instance that is a 1-year heavy utilization reserved instance. And so heavy utilization means you would tend to predict that this web server is going to be used consistently. It's going to be on almost all the time. And so if that's the case, then you'll actually get better cost savings using a heavy utilization reserved instance. So if you ran the Linux version of this instance, it would cost you, additional to the content delivery, it would cost you $62 up front and $3.66 a month. So over the course of the year, that would amount to, if you divided it up on a monthly basis, that would amount to about $8.83 a month. And so we're going to move on to the next architecture where, again, now what we're doing is we're adding a relational database, and we're doing this with Amazon RDS. If you're not familiar with Amazon RDS, I'm just going to, it's a managed database service. We handle backups, we handle patching, we handle some of the other sort of database administrative tasks that you may need to take on. Instead, we can take those on for you, and we offer that for MySQL, SQL, and Oracle. This architecture, again, it has many of the same limitations as the single VM architecture, and the best practices are really largely the same as well. One additional feature, though, is that your database will be placed in a separate security group, and it will be decoupled from your web server. And so you do get that added level of security by separating those two tiers of your application. In this setup, the only access to the DB can be set to be from the web server or for an admin who might want to communicate with the database specifically. So when we add in a 1-year heavy utilization reserved instance, in this case, again, a micro for MySQL, that would be $62 upfront and $5.76 a month, which would amount to about $10.93 a month. So without the data transfer, you'd be looking at something, if these were both micros in the situation I set up, this would be about $20 a month. And if we added the sort of $1.20 back in for the delivery of static content, this would be about $21 a month. And so just wanted to give you an idea of costs we change through these architectures. The variables are going to increase significantly as we continue to go through the steps. And so just for the more basic ones, I felt it might be helpful to give an overall view of what those costs look like for these different architectures. So moving on to step 3, we're going to be moving on. We know we're now larger, right? We know we're not going to fit in a single VM or a single VM and single DB architecture. So what we need to do is we need to, we're going to be breaking up the web servers, and so we're going to need to have a separate database as we go to multiple web servers. And so you need to decide whether you're going to be using DynamoDB, RDS, or EC2. And so Amazon DynamoDB is our fully managed NoSQL database that can really handle any level of read and write traffic, and it returns it can handle writes and reads with single millisecond latency, and it's very consistent. Also, it really requires no administration. We already covered Amazon RDS, but if you would like to run a different database technology, or if you would prefer to manage the database yourself, then you'd be using Amazon EC2. So this is a key step in terms of developing what you have for your architecture. In most of the architectural diagrams I'll have moving forward, I'll generally use Amazon RDS, but you could substitute in Amazon EC2 or Amazon DynamoDB into what those diagrams would be in the database tier of the architectures. Another question you're going to have to ask yourself after this one is your application 2 tiers or is it 3 tiers? And one of the main things to consider in this question is if the logic or calculations in your website or web app are too process intensive for your client or too intensive to live on your web servers. And one additional reason is it may be easier to manage them from a centralized virtual machine or cluster of virtual machines, again, rather than continually pushing updates to the app to all of your web servers. Then it's probably a good idea to create a separate application tier. But if not, 2 tiers is probably a better setup for your website or your web application. So we're going to go on to a 2-tier architecture that is using Amazon RDS. So again, if you're using Amazon DynamoDB or Amazon EC2, you could substitute that in here as well. And so the main difference between the 2-tier architecture and really that single web server, single database architecture is we're going to use an elastic load balancing service, and we're also going to start running our web servers in multiple availability zones in auto-scaling groups. And so if you need 2 web servers, if your app or site is large enough to have 2 web servers, then you should definitely utilize multiple availability zones because you'll essentially be adding increased reliability with no additional cost to do so. And we can also please note that if you were using Dynamo in the database portion of your tier, that Dynamo already builds in high availability and data durability to your database. If not, then in this case, you're looking at RDS in a single AZ deployment. We'll get to a question later in sort of this decision tree of whether you would want to have a multiple AZ deployment for even higher availability. And then also, if you're using EC2, we recommend putting that database in an auto-scaling group with a min of max of 1 as well, so that if it were to go down, it would automatically restart and your database would come back up online. So moving to a 3-tier architecture instead of the 2-tier, we're really now adding an internal elastic load balancer. You need to use Amazon Virtual Private Cloud to use our elastic load balancing service internally. If you did not want to do that, you could use Amazon EC2 here and load load balancing software such as HA proxy in an auto-scaled application tier that would then also be in each availability zone. You could have your app tier in just one AZ, but again, that may decrease reliability of your app. And it would likely, more importantly, increase latency for requests that were coming from one AZ and then would need to go to the other AZ to interact with the app tier of your application. Also, again, note that sort of this framework of the static website is still moving throughout all of these architectures as we continue to add complexity in multiple tiers of these apps. It's still a critical component to running these websites and web apps as efficiently as possible. The next question is, well, do you want search in your application? A lot of content management services offer search functionality, at least some basic search functionality in their software. We offer a sort of very high performance, high scale search product called Amazon Cloud Search, and it really makes it easy to manage powerful search engines. And so the architecture in this case, if you really want to add that kind of, say, high-powered and really great search functionality to your app, is very simple. Again, we basically are just expanding on the three-tier architecture that we set up in the last diagram, and just again tying in search, which is actually very easy to do with Amazon Cloud Search. And so the next question you'd want to ask, which is step 6, is do you need a cache layer? And so for any application or any website where you're having common database read requests, using a cache can really speed up the performance of your application, and it can take load off of your database, which allows you to more easily scale your database, and it can allow you to operate with a smaller database overall, which can save you money. Really, this is most applications. It just sort of depends on where you want to run your cache. Like, you may run your cache on your web servers if you're in a 2-tier setup. You may run them on your application servers if you're in a 3-tier setup, or you may set up, you may actually want to set up your centralized cache cluster or of varying cache nodes to handle this type of traffic. And so when it gets to the point where adding your own cache layer or cache cluster makes sense, we have a product called Amazon Elasticache, and I'll show you what that looks like in the architecture. So this is the same architecture, 3-tier architecture that already had search. We just added cache, as you can see on the right-hand side of the diagram. And so with Amazon Elasticache, it just makes it very easy to set up a Memcache compliant cache cluster with as many cache nodes as your application requires to run effectively. And then also with Amazon CloudFront's dynamic content feature, what you may realize is that you can actually push some of that cached information that's updating, we'll say very often, actually out to the edge. And that will actually help your app run even faster, and it will continue to take load off of your overall 3-tier architecture. I mean, it'll take load off your web servers, it'll take load off your app servers, it'll take load off your database, and so forth. So I'd really take a look at CloudFront's new dynamic content feature as it has a 0 time to live, and you can really start pushing that type of content that you might actually be updating rapidly in a cache out to the edge as well. So on to step 7, really our last step is, if you're using RDS or if you're using EC2 for your database, does it need to be highly available? And again, this is just one of those Santa Ana fires in California. This is a picture from NASA JPL. And down there's one of their facilities where they had data centers. And as this fire was approaching, they realized that they had quite a few apps that had dependencies within a single data center. And so depending on your needs for your app or your website, you may want to extend that to actually have your database ready in a separate availability zone. And so with Amazon RDS, they make that really easy while you're setting up your Amazon RDS instance. Part of that process through the management console is you can really single-click enable your Amazon RDS instance to work across multiple availability zones. And what we've done is ensure that we actually do synchronous replication of your data. And so if at any time there's an issue in one availability zone, we can fail over, and we would do that for you with RDS into the other availability zone to keep your app running well throughout. So again, these are sort of the seven steps to go through that will get you to a good reference architecture. You still need to make decisions on the instance sizes depending on the amount of traffic that your application gets, and also you need to make decisions about, is your application more compute intensive, is it more memory intensive, as Amazon EC2 has instances that work for all those different types of applications. These are some other services that can actually aid in your apps as well. We have a simple queuing service which can help you build loosely coupled applications. We have Amazon Simple Email Service, so you can build transactional email into your applications. Simple Notification Service, and then Simple Workflow Service, depending on what your app's needs are, can be added into any of those architectures that we already talked about. And again, earlier we were talking about cost. So I thought it would be helpful to just call it, we have a calculator called the Simple Monthly Calculator, and you can go to this calculator, the link's at the bottom of the slide, and start entering in those different components of what we talked about in the presentation today. And this should give you a really good estimate of what you think your monthly bill would be. Again, in the cases where I didn't spell out the pricing model, whether it was on demand or in a reserved instance or medium utilization, that is going to be something that you're going to have to make the decision on in the calculator to get a price that is right for your specific application overall. So with that, I want to thank you all for joining today. We're looking forward to, if you have any questions that we can answer about this. And also we're looking to learn more about, just learn more about what your needs are and if this content is helpful for you and your situations. But thank you all, and please let me know if you have any questions.
Thank you, Reed. Now we're going to take a few questions from the audience. Please submit your questions now, and we'll start with a few that came in during the webinar. And the first one that we had is whether we can send out a few of these resource links that were found in the presentation to the attendees.
Oh, absolutely. I'll be making we are recording this presentation, and so we're going to make this recording available as well as the slides, and you'll definitely be able to access the links that are in the presentation from the slides themselves. So the next question is from Dean, and Dean's saying, regions fail, why are you not recommending failover across multiple regions? And so really the multiple availability zones are really independent, are set to work for the vast majority of customers to achieve very high levels of availability. I think you'll find that if you set up, even in a single region, with multiple availability zones, you're going to have a very fault-tolerant architecture, especially if you start moving the majority of your app, like as much of your app or site out to the edge as possible. That way, even if there were to be an issue where you weren't able to, we'll say, scale up your web servers in the availability zone that you failed over to, you'd be handling most of the load from the edge anyway, and then that's a really good way of ensuring that you're getting a good delivery for your customers, even in the case that an entire availability zone might go down. So if you have any other questions, you can reach me. My email, I don't have on a slide right now, but my email is readmal, it's R-E-A-D-M-A-L @amazon.com, and we can talk directly about that. But I really want to just thank everyone for attending today's webinar. And like I just stated at the beginning of the Q&A, we will be sending out links to the content that's in this. But I'm also really looking for feedback on this content. So if you found this helpful, or if you would like to have covered something different or something else in this topic, please do let me know. This is really the content we're trying to put together to help our customers really deploy the applications and websites in the way that's really right for them, depending on their specific requirements. Well, thank you again for attending today.